Hey guys, how's it going? So we're continuing with our paper. Okay, so today we're going to do this question 19. What does it say? It says one day in 2016 the population of Nepal was this much. Okay, so it's 28,795,701. Write this number correct to three significant figures. Okay, so we want to correct this number to three significant figures. One of the things that you have to know about changing the presentation of numbers or approximating numbers is that we actually don't change the value of the number, at least in some sense. Okay, so for example here, this one, someone may be tempted to think, for example here, the first significant figure is the first non-zero digit, so 1 would be the first significant figure, would be 2 here, and then second, and then third. So this one would be the third significant figure. Okay, so you're actually supposed to look to this. So someone can be tempted to say round up, and then this becomes 288. So here you've changed the number altogether. This one was 28 million something. This one is just 288. Big problem. Okay, so you don't do that. Approximation or change in presentation preserves the basic value of the number. Okay, so for example here, you'd actually have to put placeholders. So it would be 288 here, then this one has to be replaced by 0, this one as well. So we're dealing with 5 zeros here, so you should replace the 5 zeros. So it should be like this. Okay, so it's actually 28,800,000. So you see, this one was 28,795,701, so which is quite close to 28,800,000. Okay, so this is the essence of our approximation. So the next part, it gives us this table. Okay, so I'm going to delete this part, and then I'm going to show you the questions for the next part. So the questions, they say the population of India was approximately 130 million. Okay, in the table above, complete the row for India. Write the number in standard form. So you're supposed to write for India here. We are told that this is supposed to be 130 million. Okay, so 130 million like this. And to write this in standard form now, because all these are written in standard form, and also to two significant figures here, we're supposed to follow the same pattern. So 130 million in standard form, it's essentially this form where a times 10 to the power n, where a is any number which is equal to or greater than 1. So it can be 1, it's allowed, but then it should be less than 10. So 10 is not allowed, but then 9.99999 is allowed. Okay, it just has to be less than 10. So here the way that we adjust is this one becomes 1.3 times 10 to the power, this n here, it's an integer. It represents the number of shifts that you have done. If you shift to the right, then you're looking at n being a negative number according to the number of steps, the number of shifts to the right. If you shift to the left, then you're looking at n being a positive integer according to the number of shifts again. Okay, so the comma is actually here. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's supposed to come to here. We have shifted 8 places to the left, so our power has to be positive. Okay, so we're dealing with 1.3 times 10 to the power 8. Okay, so we didn't change the number. We didn't change 130 million. We just changed the way we present the number. Okay, so that's what we did, and we did it well. Okay, so let me delete this part because we don't need it. Next part says calculate the total land area of India and Nigeria. Okay, so calculate the total land area simply means add the total land area for India and Nigeria. So India here, the land area is 3.3 times 10 to the power 6. This one is 9.2 times 10 to the power 5. Okay, so essentially we want to add, let me write here. Okay, so 3.3 times 10 to the power 6 plus 9.2 times 10 to the power 5 here. Okay, so this is what we will be adding. So let me turn off this so that we can add. We can simply add. Okay, so here what we do is we have to match the powers here. So this one is 10 to the power 6, this one is 10 to the power 5. We have to match them. So I advise you to match them to the highest or higher power. So in this case, the higher power was 10 to the power 6. So the way that you do it is this one, it's equal to 3.3 times 10 to the power 6 plus 9.2. Here you want to change 10 to the power 5 to make it 10 to the power 6 somehow. So the way that you do it is you say 10 to the power 6 minus 1, because 5 is simply equal to 6 minus 1. Okay, so that's it. So if you have done this, the next part you actually have to expand this part here. So this one becomes 9.2 times 10 to the power negative 1 times 10 to the power 6. Remember, 10 to the power 6, this is what we want. So we want to change this one to a number. So this one becomes 3.3 times 10 to the power 6 plus this one becomes 0.92 times 10 to the power 6. Okay, so this one is great. And then here, 10 to the power 6, we can actually just factor out 10 to the power 6 here. So we just simply get 3.3 plus 0.92. Okay, so 3.3 plus 0.92, 3.3 plus 0.92 here, and here we're adding, and then this one you get 2, this one you get 12, so 2, then you carry 1, this one you put the comma back, this one you get 4, so you get 4.22, so it'd be 4.22 multiplied by 10 to the power 6. Okay, this one must have been in kilometers, I'm not sure, but I think it was area, right? So it must have been square kilometers. Let me actually check which one was it. So yeah, so it's in square kilometers. So that's what we got right there. Okay, so we can let me check out the next part. The next part says which country in the table has the smallest population per square kilometer. Okay, so which one has the smallest population per square kilometer? That's what we have to discover. So smallest population per square kilometer, that means we are comparing this divided by this, we are comparing. Okay, so this divided by this, we are comparing. So the way that I advise you to compare is you can first eliminate what you think that will be very small. So we're looking at the smallest population per unit area. So we're looking at which ones would give the smallest number here. So the smallest population per unit area, that's what it means. Okay, so this one will give you a negative, this one divided by this, so this one will give you a positive power. So this one with positive power, this one will give you a negative power. So this one, let's consider it. Obviously it would be smaller than this one. Okay, since this one, the population and the area, this area, it's massive, so you're actually getting a fraction per square kilometer. So this one is good. So we're going to for this one, if you divide this one by this one, you actually get something positive here. Okay, so we're going to remove this one as well. So for this one and this one, it's also the same thing. You're actually going to get maybe hundreds or thousands of people depending on what you do. So this one and this one, then you're supposed to get, you will get something positive here. So the country which gets the smallest population per land area, it's actually this Greenland. Okay, so we did by inspection. You can say by inspection, Greenland has the smallest population per land area, and you can justify it by saying only Greenland has less than 1 person per square kilometer. Okay, so you can actually see this by saying the population divided by this. Obviously 5.6 times 10 to the power 4 divided by 2.2 times 10 to the power 6. Okay, so here you get roughly let's just say 2 here. Okay, so I'm approximating because we are not concerned with the actual values. So 2 times 10 to the power negative 2 here. Okay, so this one, it actually does make sense. So you're looking at less than 1%, so per square kilometer. So with the others, it's not that. So sometimes you have to compare by inspection. I'm sure this one was like 1 mark or maybe 2 marks, but this is how you'd explain. You explain saying by inspection, the population of Greenland is the smallest in terms of population density. Okay, that's it. So you'll be done with this part. Okay, so if you haven't subscribed, I advise you to. This is a good place to learn. I think we're adding so much value there. So comment, sometimes even like the video. It helps others discover our channel, okay, so the other students like you. At any rate, thanks so much for watching. This has been Yuba. I'll catch you in the next one. Cheers.